I just, okay. So, when we talk about acids, if you remember, the acids are substances with pH number between 0 to 7, okay? Or at any pH less than 7 is what we call acid or acidic. And when we talk about bases, if you remember that, okay? So bases are any substances with pH numbers between 7 to 14. That's what we call as bases, okay? That's what we call as bases. And then when you mix acid and base, what happens is that they go into a chemical reaction, okay? They go into a chemical reaction. And then what do we call this chemical reaction, if you remember? Neutralization reaction. But why do we call it as a neutralization reaction? Because they neutralize the effects of each other. So which means that when you add acid into base, the properties of base decreases, okay? The base becomes weaker. When you add a base into acid and the properties of acid decreases, which means acids becomes weaker, okay? They make each other weaker, okay? And then in somewhere in the middle is pH 7 is what we call as neutral, if you remember from previous classes. I'm trying to move to the content. Okay, today what we are going to talk about is the general reaction of an acid with a metal oxide, okay? Metal oxide is actually a base, okay? Metal oxide is a base. What is metal oxide? Metals, for example, let's start with metals. Metals are elements on the left-hand side and in the middle of the periodic table. I showed you lots of examples if you remember, and then you can give me lots of examples like iron, aluminum, calcium, potassium, sodium, okay? And then when they make chemical formulas, okay? When they make compounds, okay? When they make compounds, what happens is that and they form metal oxide like sodium oxide, calcium oxide. These are what we call as metal oxides, okay? These are what we call as metal oxides. And then we know that the metal oxides are bases. How do we know metal oxides are bases? Because they tend to have pH more than 7. That's how we know that, okay? And an acid, when an acid goes into reaction with a metal oxide, what happens is that and they produce a salt and then water. That's what we are going to talk about today. And when a metal reacts with oxygen, that's what we discussed in the previous classes. And metal, and then when you burn a metal, actually, that's what we call, when you burn a metal, you see different flames, okay? And then after that, ashes coming out. Those ashes are what we call as, okay? Or the gas coming out from that is what we call as the metal oxides, okay? And then they tend to form, and when the metals react with oxygen, they tend to form oxides, okay? Oxides means compound, okay, or molecule is composed of a metal and oxygen, okay, like NaO, CaO, okay, Na2O or CaO, okay, like calcium oxide, sodium oxide, okay, like iron oxide, Fe2O3, for example, which are bases. See the reactions of metals with oxygen. That's what we discussed before. I just revised it for you. And the next point, when an acid reacts with a metal oxide, okay, and then in this case the metal oxide is a base. So when an acid reacts with metal, when an acid reacts with base, what happens is that we produce salt and water, and the products formed are salt and water, okay? Any kind of acid base, we produce salt and water. Is it possible to have salt only? Yes, okay. There is one case I remember, it's in my mind. For example, when okay, when an acid and a base goes into reaction, it only produces salt. Okay, so it's possible, but generally what we see is that it produces salt and water, and the type of salt formed will depend on the specific acid and metal oxide. So what we mean by this, okay, we are talking about the bonds are broken in the reactants on the left hand side. When the acids and bases goes into reaction, what happens is that and then new bonds are formed, okay, new substances formed. That's what we call as a chemical reaction. So which means that to be able to understand and what kind of salt is produced, what is the name of the salt, we need to look at the refer to the acid and the metal that goes into reaction, okay? Acid and metal oxide that goes into reaction. And the part of the acid and the part of the metal oxide, they come together to make the salt. That's why we need to know what acid and metal oxide goes into reaction to be able to identify the salt produced, okay? And then in chemistry, okay, in natural science, basically in field chemistry, we write general equation for some chemical reactions, okay? For example, a reaction between an acid, any acid, okay, and then between a metal oxide, okay, and then I want to write down what is produced generally, okay? That's what we call as general equation, okay? And then if you want to write down the general equation for the acid and metal oxide, you can just write acid plus metal oxide will produce, this arrow is showing us the chemical reaction. When they go into chemical reaction, what will produce? Salt and water. This is not the salt as we usually have. We can produce that salt, not the salt that we have, okay? It's what we call a chemical salt, okay? And plus water. As you know that the water is a molecule, it's H2O, okay? And then one example is here, that's what we are going to focus on today, and then more examples, inshallah. And then we can show some specific examples by using a word equation, by writing down names and putting in the form of chemical equation, or we can use their symbols, okay, and then that's what we can write a balanced chemical equation. For example, hydrochloric acid, we discussed this before. Hydrochloric acid is a strong acid, if you remember from the previous classes, okay? It's a strong acid. When it goes into reaction with magnesium, magnesium is on the left-hand side of the periodic table, it's a metal. And oxide means MgO, okay? MgO is the magnesium oxide. So it's a it's a molecule, okay? And it's a compound, sorry, it's a compound, and that is composed of a metal and oxygen. That's how we call magnesium oxide. And then they go into reaction to produce magnesium chloride. Magnesium chloride, how do I know, okay, magnesium chloride is produced, okay? And then plus water. We know that always water is produced, but how do I know is that we just need to highlight, okay? So the hydrochloric acid, in the hydrochloric acid, what we have except hydrogen? Cl, chlorine, as you can see. And then magnesium oxide, what is the metal in magnesium oxide? Mg, okay? So what happens is that not the hydrogen in acid, not the oxygen in metal oxide, other elements, they come together always, they come together to form the salt, okay? So what is going to happen? Magnesium chloride. Why magnesium is first? Okay, why magnesium is first? Alaikum salam. And then why magnesium is first? Okay, because always when we write down an ionic compound, okay, ionic compound, this is an ionic compound, and then what happens is that the metal is first and the non-metal is second. Chlorine is on the right hand side in the group 17 if you look at the periodic table. So the magnesium, chlorine, chloride, you know the naming, okay? So that's how we can identify. And then after that, we can just write down HCl is the hydrochloric acid we know from, remember from previous classes. Magnesium oxide is MgO, and that is going to produce MgCl2, magnesium chloride plus water, okay? And in this case, if I ask you, what is the salt produced? You can just say magnesium chloride. What is the symbol of the salt form? MgCl2, okay? And then we are going to talk about some applications if we have time later, okay? So that's what we need to discuss, okay? So I just did discuss briefly. Now I'm going to talk about one by one what we need to know about this reaction. Okay, before we talk about the reaction between acids and the bases, acids and the metal oxides. In this case, metal oxide is the base. And then we need to know what is metal oxide, where does it come from? Okay, let's look at what is metal oxide, where does it come from? When metals react with oxygen, any kind of metal that you can find on the left-hand side in the middle of the periodic table, like K, potassium, like Fe, iron, like, okay, like I'm talking about Mg, okay, magnesium, Al, aluminium, Zn, zinc, Na, sodium. These are on the left-hand side in the middle of the periodic table. These are metals. And then what happens is that they react with oxygen. Oxygen is in the form of O2, oxygen gas. That's the one in the air. And then when you start the reaction by using a flame, by heating up, okay, it will catch a flame, okay, and then they can give you different colors, different metals. And as a result of this, it's going to produce a product. That's what we call oxides, okay. And then these oxides, when metal goes into reaction with oxygen, it produces a metal oxide, and the metal oxides are bases, okay. They have pH level more than 7 when you mix with water, okay. That's how we know. And then I'm going to show you some metal oxides with their names, symbols and names, okay. And then you are going to follow me up, please. The first one is on the left hand side, magnesium oxide. So if you look at the right hand side, which one is magnesium oxide? Very easy to find. This is magnesium oxide, okay. Let's look at another one. So the zinc oxide, I want to find the zinc oxide, okay. Zinc is the metal and the other one is oxygen. So I need to look for the symbol for zinc, Zn, and the oxygen is O. Where is Zn and O? Okay, that is zinc oxide. And another one, okay, let's look at another one. Sodium oxide, I'm looking at sodium oxide, okay. Sodium is Na, oxide is O, okay, Na2O, as you can see. Aluminium oxide, another one, I'm trying to use another color for this. Aluminium oxide, Al is the symbol for aluminium, and oxygen is O, Al2O3, okay. Why this one is 2, why this one is 3? Because of their chemical properties, okay. And the next one is a different color. I'm trying to carbon dioxide, C and O. I'm looking for C and O. As you can see, this is carbon dioxide. And another one, iron oxide, Fe, the symbol for the iron, you know that, okay. And the oxide is oxygen, Fe2O3, okay. And the potassium oxide is our last metal oxide, okay. We are trying to find the names and the symbols. Potassium oxide, K2O, okay. So these are our metal oxide. How do they form? They go into reaction with the oxygen gas in the air, and they produce these powder forms. That's how I can call it. And by the way, Fe2O3, you remember this from somewhere? That's what we call rust. You remember we discussed rusting? Okay, this is the rust, that brown, reddish, okay, reddish brown, okay, how can I put it in this way? Reddish brown powder on the top of, okay, iron metal that forms during the time when you leave your metal outside, for example. That's what we call rust. And what about, okay, if you have any questions, you can just type it on chat, okay, and then I will try to answer your questions. So I gave you one example of metal oxide is rust. Rust is the metal oxide, the chemical produced as a result of rusting is metal oxide. So let's remember what is rusting. I found this nice diagram from internet, okay, you can find too many others. So what happens is that iron pipe, usually we see in the iron pipe, sometimes you are having a bicycle and then there is a chain on the bicycle. That chain, it has iron and some other metals maybe, okay, there's iron inside. Imagine that it's only made up of iron, and then what happens is that when you leave it outside for a while, and then when you use it for a long time, and then when you don't, for example, you have a bicycle chain, when you don't put some enough oil on it, okay, when you don't put some oil on it, okay, and then what will happen is that it will start getting into reaction with the oxygen in the air, okay. And then when it goes into oxygen within the air, as you can see, oxygen in the air, and then you know that the atmosphere is composed of 21% of the atmosphere is composed of oxygen. We have lots of abundant, okay, or amount of oxygen in the air, and then when they go into reaction, there is one condition that we need the humidity in the air, okay, we need water in the air. If there is humidity, water, the reaction happens very fast, okay. And then that's going to produce rust. As you can see, it is the reddish brown color on the top of the iron, and then when you just rub it, you can reach to the original iron. It's a silver shiny color, okay, reddish brown, not shiny, dull color, particles on it. It's what we call as iron oxide. Can you see this Fe2O3? That is iron oxide, that different color. As you can see on the chain on the right hand side, that is the iron oxide, okay, that when you just brush it and then you can see the iron is coming out, that powder coming out is what we call iron oxide. That's the metal oxide, and the metal oxide is a base, okay. And then what happens is that, what is the reaction? You remember, iron goes into reaction with oxygen, And there is one more condition that we need is the humidity in the air. If there's humidity is higher, the reaction, the rusting will happen faster, okay? And that's going to produce iron oxide. That's going to produce iron oxide on the right hand side, okay, as you can see. I'm moving to the next, okay? Now we know how the metal oxides are formed, and we know some examples of metal oxides. And what about these metal oxides when they go into reaction with acids? And then what will happen is that's our question today. And I gave you the example actually is that metal oxide is a base, and then acid, when acid goes into reaction with a base, what do we produce is that salt and water, okay? That's what we call neutralization reaction. So can I say that acid and metal oxide reaction between acid and metal oxide is actually a neutralization reaction? It's a type of reaction. That's what we call acid base reactions. So what do we do today is that we just look at some specific examples of acid going into reaction with bases to produce salt and water. One example is metal oxide, okay? So let's look at the first part. When an acid reacts with a metal oxide, the products are formed are salt and water, okay? What is the general equation? Acid plus metal oxide is equal to, or producing, this arrow is showing us producing, goes into chemical reaction, and then producing salt plus water, okay? And on the left hand side of the chemical equation, general equation, these are what we call, if you remember, on the right hand side, what do we call this? These are called, if you remember, reactants, okay? Reactants. Somebody came in now. Reactants, okay? And on the left hand side, on the right hand side, what do we call this as? After the reaction is completed, what we have in the container? Products, okay? So which means that if I ask you a question, what are the reactants for reaction between acid and metal oxide? And then you can easily tell me that the answer is going to be acid and metal oxide are the reactants. What are the products of this general equation? Salt and water. So what will we produce if we have an acid and metal oxide goes into reaction? In general, you can say that salt and water. Products are salt and water. And the type of the salt form will depend on specific acid and metal oxide, because one part of the acid and then one part of the metal oxide, they come together to form the salt. So if I know the acid and the metal oxide, and then I can tell you which salt is produced, what will be the name of the salt, and what are the elements that forms the salt. And the one example that we just discussed is the word equation. Word equation means that you write this general equation by using the specific names of acids and metal oxides. And then one example is HCl is the hydrochloric acid. Okay, the name plus, okay, magnesium oxide, and then goes into reaction producing magnesium chloride plus water, okay? And then when we talk about balanced chemical equation, how we write on HCl, HCl is the formula, MgO is magnesium oxide. Do we need to know the name and the symbols of these magnesium oxides and acids? Yes, we have to memorize, okay? I want you to refer to the previous slides, okay, that we discussed in the previous classes, and these slides, okay? And then memorize the ones that I gave you. Those are very important, okay? And then MgCl2, what is produced is MgCl2, yes, magnesium chloride. How do I know this one is magnesium chloride? I'm just giving you a shortcut, okay? Look at here, please. H in acid and O in magnesium oxide. They come together to produce HNO, as you can see, water, okay? And what is left? What is left that didn't form something, okay? Cl in the acid and Mg in the metal oxide. So which means that not the H, other element in the acid and the metal in the metal oxide, they come together, as you can see, Mg and Cl, that's going to produce MgCl. And I can tell you the name directly. The metal name is first and the non-metal name is second. Cl is non-metal, MgCl is magnesium chloride, magnesium chloride. You can easily see that, okay? And plus water, you know the formula for water, H2. And then you need to balance the equation. And how do we balance the equation? On the left-hand side, on the right-hand side, we must have equal numbers of hydrogen, chlorine, magnesium, and oxygen, okay? That's how we balance it, by using the numbers that we put in front of each formula. Okay, you remember this. Okay, just refer to the previous classes, how do you balance the chemical equation. And then I found some more examples for you. Okay, I found some more examples for you. Somebody came in just now. Okay, what are these examples is, as you can see, Na is sodium. If you look at the periodic table on the left hand side, okay, it's in group 1. So that's a metal. And O, oxygen. So this is metal oxide. Metal oxide. Sodium oxide. The name is original name. And HCl, you know that HCl is hydrochloric acid. When they go into reaction, what do we produce? Sodium chloride. How do I know it's sodium chloride? Salt produce. And the metal from the metal oxide, and the other element in the, not hydrogen, the other element in the acid, and the NaCl, sodium chloride, they come together to form the salt. Okay, and oxygen and the hydrogen, okay, they come together to form the H2O. Okay, that's how we can identify. That's why we should know the acid and bases, exactly the formula or the names, to be able to identify which salt is produced. Okay, let's look at the next example. And the magnesium oxide, metal oxide, that goes into reaction with hydrochloric acid. Hydrochloric acid, this is the name. Okay, I'm just showing you the word equation. Okay, I'm just giving you the word equation verbally. And then that goes into reaction to produce magnesium chloride. How do I know magnesium chloride is produced? Mg and then Cl from the other one. Okay, Mg and Cl comes together always like this. Okay, to produce MgCl2. Okay, magnesium chloride, and then H2O. And what about CuO? CuO, Cu is copper somewhere in the middle in the periodic table. It's a metal. You can check by using the periodic table that I shared before. And then the Cl, as you can see, HCl is hydrochloric acid. We know that. And Cu and Cl, they come together to form the salt. CuCl is copper chloride. Metal is first, as you know, metal is copper, and the non-metal is chlorine. Okay, chlorine is non-metal. Metal, non-metal in this order. And the name is going to be copper chloride. Copper chloride. So copper oxide goes into reaction with the hydrochloric acid to produce copper chloride plus water. That's how we can name this reaction. And other examples, I'm just going to skip these ones. Okay, I just want to skip these ones and then move into this. And then mercury oxide goes into reaction with hydrochloric acid, and the mercury and the chlorine, they come together to form our salt. What is our salt? Mercury chloride. Okay, and then O and H, they come together to form H2O. Okay, another one. Mercury oxide, metal oxide, goes into reaction with H2SO4 sulfuric acid. And then what happens is that, and then not hydrogen in the acid, not oxygen in the metal oxide, other two. Okay, let's take the other two with a different colors. And the mercury and the sulfate, this is called sulfate, you remember this. They come together to form mercury sulfate. That's our salt. How do we name the salt? And the H and O, they come together to form the water. That's how we identify the chemical reaction. So the reaction is mercury oxide plus sulfuric acid produces mercury sulfate plus water. Okay, and the other one is zinc oxide. As you can see, that's metal oxide, goes into reaction with hydrochloric acid. What will be the products? I know that zinc is the metal, and the zinc oxide is metal oxide, goes into reaction with hydrochloric acid. It's an acid. Acid metal oxide produces salt and water. How do I identify salt and water? Very easy. Zinc is the metal, Cl is the non-metal, and then they come into form together to form zinc chloride, and then H and O, they come together to form for us water. Okay, so zinc oxide plus hydrochloric acid producing zinc chloride plus water. And zinc oxide, metal, goes into reaction with sulfuric acid. What do we produce? Zinc and then sulfate. They come together to produce zinc sulfate. That is the salt. And plus H and O, they come together to form water. So what is the reaction if you read the reaction in words? Okay, zinc oxide plus sulfuric acid produces zinc sulfate plus water. And the last example, let's look at the last example. Zinc oxide, okay, okay, plus KOH. Okay, this is actually a base. Okay, I'm not going to give this example. This example we are going to discuss later. Okay, I'll discuss. This one is potassium hydroxide. This is a base. Okay, we are talking about acids today. Okay, I'm just going to skip this. This is a base. Okay, and then this is from a textbook, another textbook. I just want to show you some more examples. Okay, and how do we write the word equation for a reaction between acid and metal oxide? Magnesium oxide and hydrochloric acid. Magnesium oxide MgO and the hydrochloric acid HCl, and the magnesium and the chlorine here, okay, they come together to form magnesium chloride plus water. And then after that, what you need to do, you need to have a balanced equation. Okay, you must have equal numbers of each element on the left hand side and the right hand side of the row. You know how to do it. Okay, just refer to the previous classes. And one more person came in, mashallah. Okay, the word equation, calcium oxide. Calcium is a metal. Check, and it's in group 2 on the left hand side of the periodic table. Okay, and the oxide is metal oxide plus sulfuric acid, H2SO4. I know sulfuric acid. We gave lots of examples just now. Okay, and the calcium and the sulfate in this. Okay, calcium and sulfate, they come together to produce calcium sulfate. That's our salt plus water. Okay, the other one is water. Other one is water. Always like that. Okay, and plus sodium oxide, okay, Na2O, okay, and then nitric acid, NaNO3, okay, NO3 here and Na here, they come together, sodium nitrate, okay, that's our salt, plus water, okay, and the first one is the word equation. We have last 10 minutes, I'm going to finish now, and then this is the balance equation. That's how we can write down. So we're going to ask you, I'm going to give you like this two, for example. I'm going to give you this one and this one. I'm going to ask you to write down products. And then I'm going to ask you to write down the word equation. And then I'm going to ask you to balance the equation after you write down the products. Okay, very easy. You just need to focus on these examples. That's all we need. And then we said we are going to talk about some applications. And then I'm going to talk about some applications of reactions of acids with metal oxides. Okay. Burning wood and fossil fuels releases carbon dioxide. What is carbon dioxide? And sulfur dioxide. What is sulfur dioxide? Okay, these are oxides into the atmosphere. Okay, and this combined with water in the atmosphere to produce acid rain. I remember this one from somewhere. If you remember, in the previous class we talked about acid rain, and then what happens is that when you burn the fossil fuels, okay, when you burn the fossil fuels, okay, and the wood, it produces carbon dioxide and sulfur dioxide, and then these ones, they go up in the higher in the atmosphere. When they meet with the water in the air, okay, they go into reaction with water to produce acids, and then acids, they go back. Okay, these acids formed in the form of clouds, they go back onto the ground. Okay, they go back onto the ground in the form of precipitation, like hail, snow, rain, and that's what we call acid rain. This is one application. And the other one is the limestone. Okay, limestone is calcium carbonate, is used in agriculture. Okay, when we talk about carbonates later in the next class, okay, I'm going to talk about this more to make the acidic the soil less acidic. Actually, it's a base. Okay, this is calcium carbonate. Calcium carbonate is metal carbonates. Okay, not metal oxide. This is metal carbonate, and then this one is actually what we call as it's a basic substance. Okay, and then we use it for in the form of fertilizer. When you put it in the ground, okay, it decreases the acidity. Okay, it makes the pH of the soil higher, and the strength of the acid in the soil will decrease, and then the plants can survive better. Okay, and the very acidic soil, the plants cannot survive. That's how I can put it in the form. And then if you put limestone, it will decrease the acidity. Okay, it will make the acid less stronger, okay, weaker, and then what will happen? And then you can grow products better. And then investigating whether the magnesium oxide, okay, and the kept from product from the burning of magnesium. Okay, so magnesium metal, if you burn the magnesium metal, what happens is that it goes into reaction with oxygen. Okay, somebody raised the hand. I don't know who raised the hand. Haja, I can't find you. Okay, he left, I think. Okay, and then please type it on chat, please. I can't find who raised the hand. Okay, and then what happens is that it makes the water is as acid or base. Okay, magnesium oxide, when you dissolve in water, it is going to make your water. Okay, when you dissolve, okay, make your water basic. It's going to make pH more than 7. Okay, what is the pH of pure water? Neutral, 7. Okay, when you add magnesium oxide, it's a metal oxide. What is metal oxide? We said metal oxides are bases. Okay, they are basic substances. When you add it into water, so it will make it more basic, and then pH of the water where you have the magnesium oxide dissolved inside, it will be close to the, okay, it will be close to the, okay, away from 7 but close to the 7. Okay, it will be higher than 7. That's how I can put it in this way. And when we test the pH using a universal indicator, these are the colors on the universal indicator. So we get a color like maybe like 9, 10, 11, like, for example, this one is how I can put it in this way, light blue, and then going into like purple color or darker blue. Okay, and then record the pH and draw the conclusions. That's what I will discuss in the next class. Okay, so until next class, what I would like you to do, I just want to show you that. Okay, please look at your screen. Okay, this is the stuff that I'm going to share with you. Okay, this is the stuff that I'm going to share with you. Okay, today this is the worksheet 1. Okay, acid reactions of acid with bases part 2, worksheet 1. And then what I want you to do is that try to answer these questions, and then next class I will do a quick revision of what we discussed today, and then we will answer these questions together. Okay, this is your homework until next class. What you can do is that you just answer these questions on your notebook. Okay, and then we will check your answers in the next class. Okay, so what did I give you in the first one is I want you to write down the general equation of metal and the oxygen gas reaction between them, and metal oxide and acid, we just discussed that. And I want you to write down the word equation and the balanced chemical equation of magnesium and the oxygen gas. They go into reaction. Okay, magnesium oxygen gas producing metal and oxygen, metal oxide. Okay, sodium and oxygen gas, metal and oxide, it's going to produce metal oxide. And another one is sodium oxide and the hydrochloric acid. What is sodium oxide? It's metal oxide plus acid. Okay, that's going to produce salt and water. So I just want you to identify which salt is it and what is the symbol, and then write down the equation. Okay, please refer to the slides that I shared these slides with you. Okay, and then try to answer these questions until next class, and then we will try to do it together, inshallah. Okay, we have 2 more minutes. Is there any questions? Somebody wants to ask any questions? Okay, you're welcome.